Hi guys, welcome again. Today we have an important but high yielding topic to be discussed, which is electron transport chain. Its complexes, inhibitors and ATP formation. We also go through a little bit discussion of related topics like uncouplers. So guys, try to take the concept first, then memorize, which will be easy for you guys. And I will love to listen from you guys in comment section what you guys want to be discussed in next video. So let's have fun guys. So let's get into it. As you know, the NADH electrons from the glycolysis enter into the mitochondria via the malate aspartate shuttle or glycerol 3-phosphate shuttle. So when these electrons get enter into the mitochondria on inner mitochondrial membrane, the electron transport chain begins along with the oxidative phosphorylation. Here the movement of the electrons will occur and coupled by the ATP production. So today's our discussion topic is electron transport chain and oxidative phosphorylation. So first of all, I will try to give a very simple and conceptual definition to you guys. So what you can write in your exams also. The passage of electrons results in the formation of the proton gradient. So the first step in the oxidative phosphorylation is the creation of the proton gradient. And like in the inner mitochondrial membrane. Inner mitochondrial membrane. Okay, and the next one is the couple to oxidative phosphorylation, means the derivation of the ATP production. So basically two things involve the electron transport chain. The first is the passage of the electrons, which results in the formation of the proton gradient in the inner mitochondrial membrane, and then this energy is utilized for the production of the ATP in the oxidative phosphorylation. So guys, then as you know, the ATP hydrolysis can be coupled to energetically unfavorable conditions. What are examples? Like I will mention some examples like sodium potassium ATPase. These are channels, as you all know. They will maintain a electrolyte balance in the cell. And the next are the binding of the ribosomes to the endoplasmic reticulum. So you can remember these two examples, which needs ATP to be hydrolyzed for the conversion of their active forms or to get out their works. So guys, here's a diagram which will clear our concepts of the electron transport chain. As you know, the electron transport chain consists of the 5 complexes. Here I have mentioned one by one, and my drawing is not good enough, but I have made an effort for you guys. So let's get. Complex 1 is NADH reductase. Basically, first I have to give an introduction of the diagram. Here's inner mitochondrial matrix, here is inner membrane, and here is the intermembranous space. Okay, then first the electrons enter at the complex 1, which is NADH reductase. Then electrons will be transferred to the complex 2, which is succinate dehydrogenase, and then further electrons will go through and coenzyme Q and complex 3, which is CoQ cytochrome C oxidoreductase. The electrons continue their transfer and they will reach to the complex 4, which is cytochrome C oxidase, and the last one will be ATP synthase. So in all this transport, there will be a little creation of the gradient of the proton, which is H positive. Here I have mentioned all the way where the hydrogen positive concentration is being created, and the last thing, ATP synthase, there will be the conversion of the hydrogen positive ions, their energy will be converted into ATP production. So complex 1 is NADH reductase, and here the hydrogen will be get out from the cell. And the uncouplers, what the uncouplers do, uncouplers basically uncouples the hydrogen transfer and the production of the ATP in these steps. So what will occur, the electrons will still be in transforming state, but there will be no production of ATP. Instead there will be production of heat, which state will be called as hyperthermia. So what is the example of uncoupler? The overdose of aspirin. Overdose of aspirin will cause uncoupling reaction and there will be hyperthermia, means it will separate the ATP production and electron transport. How this will occur? This will basically occurs to prevent the H positive concentration in the inner mitochondrial space. When there will be no concentration of the H positive ions, there will be no production of the ATP through the ATP synthase, means the uncouplers increase the permeability of this membrane. There will be no concentration gradient at all. So NADH electrons are transferred to complex 1 and which yield 2.5 ATP, and FADH2 electrons are transported to complex 2 which will yield 1.5 ATP. So this was all about ATP electron transport chain. So guys, let me know if you have any query in the comment section and we will discuss it again.